I also wanted to do an example of each type with you. So I'm going to do solving by graphing first. Solving by graphing, you need them to be in the form y equals mx plus b, which is slope-intercept form. And if you look at these two equations, they're not in the correct form. So we're going to start by solving each one for y. So I'm just going to rewrite this first one. And then I want to start moving everything away from y. So first thing I need to do is move 3x. It's a positive 3x, and the opposite is subtract 3x. So these are going to cancel out. I have negative 2y equals, I'm just going to write the negative 3x first, and then plus 4. And we can't combine those because they're not like terms. Now if you look, I have negative 2y, so those two are multiplying. The opposite would be to divide by negative 2, and I want to divide every single thing by negative 2. When I do that, these negative 2's cancel, so I have y. Negative over a negative is positive, and if you type 3 divided by 2 in your calculator, you're going to get a decimal, so just leave it as a fraction. And then 4 divided by negative 2 is negative 2. So once you get these in slope-intercept form, then you're ready to graph. And when you graph, you're going to start by graphing the y-intercept, which is negative 2. So you start at 0, 0, and you go down 2, you put a point. Then you have your slope, which is 3 over 2, which means that we're going to go up 3, right 2. You can also do the opposite, so you could also go down 3, left 2. These are really the same slope. So I'm going to start by going up 3, right 2, up 3, right 2. And then I'm going to also go down 3, right, left 2. And so you can see that I've created this line that goes across my graph. I just want to connect it, put arrows on the end. I'm going to do the exact same thing with my second equation. So I have x plus y equals negative 7, but I really just want it to be in y equals mx plus b. So to solve for y, I would want to move this x. It's a positive x, so I would subtract x from both sides. I'm going to write the negative x first and then the minus 7. Technically there's a 1 here. It would be 1 over 1, so that just helps me identify the slope. This time my y-intercept is negative 7, so I'm going to start by going down 7 and putting a point. And then I have my slope right here, which is negative 1. That means go down 1 and then right 1. Or you can do the exact opposite. You can go up and left. So it's really the same thing. So I'm going to start by going down 1, right 1, down 1, right 1, down 1, right 1. And then I'm going to go the other direction, so up and left. When you do that, you should see that right here, your two lines intersect. So that ordered pair is your answer, and that ordered pair is negative 2, negative 5. So for all the graphing problems, you're repeating that exact process. This is an example of solving by substitution. So for substitution, the goal is to have one equation that is either just x equals or y equals. And so if that's not occurring, you need to solve for one. It's easiest to find a variable with no number. So for instance, I have a y all by itself. So it'd be best for me to solve this equation for y. So to do that, similar to when I was solving for graphing, I'm going to subtract 5x from both sides. These would cancel, and I get y equals negative 5x minus 11. So now I have these two equations, and I'm going to use those for substitution. So I'm going to take this negative 5x minus 11, and I'm going to plug it into the second equation for y. Remember, when you plug in, it's really important to put them in parentheses, so I'm going to rewrite 2x plus 9. Instead of writing y, I'm putting negative 5x minus 11 in parentheses. Then I would distribute, so 2x minus 45x minus 99 equals 30. Combine like terms, 2x minus 45x is negative 43x, minus 99 equals 30. Add 99 to both sides. You get negative 43x equals 129. And when you divide by negative 43, you get negative 3. Remember that the answers to these are always ordered pairs, so you need to take this x and plug it back into one of the original equations. I am personally just going to plug it into the first one, so I'm going to plug it in here. So I would have 5 times negative 3 plus y equals negative 11. 5 times negative 3 is negative 15. Add 15 to both sides. So y is 4, so the answer to this one is negative 3, 4. So any substitution problems, you're following those same steps. And then this last example is solving by elimination. So remember, for elimination, the goal is for either the numbers in front of x to be the exact same or the numbers in front of y to be the exact same. And typically we want them to be opposite signs, so one positive, one negative. If I look at this example, neither of them match up, so I'm going to have to do some multiplication. And it's pretty easy to turn 2 into a 4, so I'm just going to personally choose that one. So if I want to get 2 to be 4, and I want them to be opposite signs, so this is a positive 4. To get 2 to be negative 4, I would have to multiply everything by negative 2. When I do that, this equation becomes negative 4x plus 10y equals negative 70. And now if I add here, here, and here, 4 plus negative 4 is going to cancel out. Negative 10 plus positive 10 actually cancels out as well, so I'm left with 0. And then 20 minus 70 is negative 50. So 0 equals negative 50 is not true. And since that's not true, this would be a no solution. In most of the other examples, this won't happen, and you'll get, x equals or y equals, and you would plug it back in.